What song is it?
Okay, so it's possible we are recording. So what we're recording, guys, is going to be the screen and not actually us. So we're going to hope that this works. And if it doesn't, I'll try something new next time.
Is this going on YouTube?
It will go on YouTube. That's correct. Okay. Really, the only time you would watch a video of me teaching is when you're not at school. So when you're at school, you're watching me. You got a real McCoy.
My voice will be on
So
it.
that's right. Your voice will be on it. So that is a good point. When I record, what you say is also picked up. This one's it's a pretty good sensitive mic. My other room mic really only picked up me, an occasional question. This mic will pick up all of you. All right, so let's go ahead. If it's the first time of year, I feel like that was a challenge. All right, number one, P of x is equal to x to the fourth minus 5x squared minus 6. This is a quartic in quadratic form. We should factor. It factors to x squared minus 6 times x squared plus 1. Okay, that is as far as it factors over the set of integers. But we can take those two factors to rewrite it in the completely linear factored form. We take this factor, set it equal to 0, and solve. Okay, so we have positive 6 and negative 6. So what that means is that I were to write the complete linear factorization, x minus root 6, x plus root 6 would be two of our factors. Okay, I take this factor and I set it equal to 0 and solve. So when I do that, I move the 1 over, and now I'm taking the square root of a negative 1, and the square root of negative 1 is I. But when I take a square root, I get the positive and the negative, so x equals plus or minus I. So my other two linear factors are x minus I and x plus I. D. Answer D. Any questions about number 1? Okay. Let's take a look at number 2. All right. Number 2 gives us P of x is equal to this nice cubic function. It's a sum of cubes. And a sum of cubes factors to a binomial times a trinomial. Now, some of you remember the mnemonic SOAP, which helps us with our signs, right? Same sign, opposite sign, always positive. Okay?
What's happening up there?
I'm guessing someone's walking on the roof. Okay. And then we do cubed roots. So what is the cubed root of x cubed? X. What is the cubed root of?
2.
Hold on. I touched something with my hand. What is the cubed root of 8? 2. Okay. So the cubed roots go there. Do you all remember that part?
Yes.
Okay. Now we can ignore this. And we know right here we do the square of the first term. So it becomes x squared. So you square the first. Here we do the product of the two terms. So the product would be 2x. And here we square that last one. 2 squared is 4. So that's a review of how to factor a sum of cubes. A difference of cubes works the same way, except the signs would be minus plus plus. Okay, now I can already see one of the zeros right here. It's very clear. That what would make that first factor equal to 0? Negative 2. So the first 0 is negative 2. Now, if I'm factored correctly, that trinomial will not factor again. So if I have a quadratic that will not factor, what do I do to solve? Quadratic formula. So I do negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This simplifies to 2 plus or minus root 12. Negative 12, excuse me. Negative 12 breaks down into 4 times 3 times negative 1. So this becomes 2 plus or minus, the square root of 4 is 2, the square root of negative 1 is I, root 3 stays under the radical, over 2, and 2 divides into everything, so I get 1 plus or minus I root 3 on my other two zeros. So, negative 2, 1 plus or minus I root 3 gives me an answer of D again. Alright, how's that for number 2? Number 3, we are asked to factor this polynomial. What method do you use to factor this polynomial? Yes, we sure do. So for number 3, my polynomial, they're really fond of P of X. P of X equals x cubed plus x squared plus 25x plus 25. We group the first two, pull out the x squared, we get x plus 1. We pull out the 25, we get x plus 1. So it gives us x plus 1 times x squared plus 25. We know every time we have a plus right here, we're going to end up with what kind of solutions?
Imaginary.
Imaginary, yeah, because when we move it over to solve, we get negative. All right, so this, what are they asking us to? Yeah, they're asking us to find them all. Apparently, if my page touches anything, it also. So this is negative 1. And then this one right here, when we take this guy, and we move the 25 over, it becomes negative. So x equals plus or minus, when we take the square root, 5i. D. Alright, number 4 is not D, by the way. Fun when you get one that's not D. Alright, any questions about number 3, though, before we move on to number 4? Alright, number 4. Continue page. Alright, we need a function with a degree of 3. We know our zeros are 4 and 3i. Guys, if 3i is a 0, what must also be a 0? Negative 3i. Okay, so if we're given the zeros, we can write the factored form. It's just x minus each 0. Oops, I left off the I. And here we have minus a negative, which makes a positive. So if we're going back to write the function now, we're going to multiply this back, and I'm going to start with the second 2. And the reason I do is because they're conjugates, and when you multiply conjugates, what happens? The outer and the inner will always cancel. So here I have x squared plus 3ix minus 3ix. There they go. Look at them canceling. Minus 9i squared. So every time this is what's going to happen. When I multiply conjugates, those outer and inner are going to cancel. I usually don't even write them. Okay? And then this becomes a negative 1 times a negative 9 makes it a positive 9. So maybe when you studied complex numbers last year, every time you had a I squared, did you slash and change? Yeah. So this is x squared plus 9 times x minus 4, which is pretty simple. We'll just do it in the right order. X times x squared. Then we'll do the squared term. Then we'll do the linear term. Then we'll do the, there we go. What is that? A? A. A.
I was kidding you too.
All right. Any other questions? Yes, sir.
Could you also do synthetic division to like see if the zeros?
You certainly could. You could do synthetic division. Now, what would be a quick way to do synthetic division? Because you just have to start trying your answers, right? So that could take you a while. Now, it worked out well because the answer was A. And if you started with A, you're very happy. But if I had tucked the answer in at D again, you would have done a lot of synthetic division. But yes, that is another method. It just might not always be the most efficient. Okay, number 5. Ooh, I like this one. My integer coefficients are 1/2. No, it says I have integer coefficients and my zeros are 1/2, -2, and I. So once again, if I is a 0, what must also be a 0? -I. Then it goes on to tell me there is multiplicity at the root. The 0 of -2 has a multiplicity of 2, which means it's a double root. So if this is a double root, it tells us something. It tells us something that we're about to have to do. So if I were to write the factor that corresponds with that -2 as a 0, would it be x plus 2?
Yeah.
And because it's a double, it needs a 2. That factor is squared. That double root also tells us what's going to happen at -2 on the x-axis.
Bounce down.
It's going to bounce. Very good. All right, now, did you guys figure out the shortcut for this? The 2 goes here. It's the opposite of that. Okay, cool. If not, you set that equal and you solve for x. Set that equal to x. And then you force it into 0. So you multiply by 2. And you have 1 equals 2x. And you subtract 1. So this was your factor that made it 0. Okay, so those are your 2 methods for doing that. All right, now we got this I. And the -I. Okay. Honestly, I did not multiply all this back. I didn't. I looked at 2 things. And I'm going to start right here. I looked at this. This times x squared times x is 2x to the 5th. So I could rule out ABC. Okay? Now, if this were not multiple choice, I couldn't do this method. Now I just have to pick between D and E. So to choose between D and E, I actually multiplied this out, which I said the outer and inner were going to cancel. So you get x squared minus an I squared. But what is I squared? -1. So it's going to turn this into +1. So that becomes x squared plus 1. So the next thing I looked at was, all right, what happens when I multiply all my constants? -1 times +2 times +1. A negative times a positive times a positive is a negative. So I knew this last term down here had to be negative.
So it's D.
It's D.
So it's D.
Again.
And I did not even multiply it out. But let's multiply it out, because that'd be fun. All right. So if we multiplied it out, this would become x squared plus 4x plus 4. And this we already have is x squared plus 1. I'm probably going to do these 2 together next so I can have 2 trinomials. It doesn't really matter. So if I did, I would get 2x to the 3rd minus x squared. This is not a trinomial. Plus 2x minus 1 times this. Maybe if you did all this. All right. Deep breath, everyone. All right, now I'm going to actually take this and come through the other one. So I'll do, that's 5. That is 4. That is 3. And that is squared. All right, that's distributing the x squared through the first polynomial. Now I'm going to distribute the 4x. And can I just line those up?
Yes.
Okay. So now I'll switch colors so we can see it. We're going to distribute this one through here. So that would make positive 4x to the 4th. 8. Yes, it does. 4 times 2 is 8. And then negative 4x to the 3rd. And then positive 8x squared. And now we got to do the 4.
Negative 4x.
Oh, and negative 4x. And now we can go back and do the 4. So the 4 would give us 8x cubed minus 4x squared plus 8x minus 4. There we go. So we have 2x to the 5th plus 7x to the 4th plus 6x cubed plus 3x squared plus 4x minus 4. Yay, we're right. Only because Donnie corrected me twice. Good try. Okay. And that's how you would do it if you had to. But if it's multiple choice and you can just kind of look at that first and then you're all right, then you should do it that way. All right, number 6, last one. Woo-woo. All right, so number 6 tells us that we've got some real, some imaginary. Use a graphing calculator to determine the number of real and imaginary solutions if this were a function. All right, so we have x to the 4th minus 5x cubed plus 8x squared minus 10x plus 12. All right, when you plug that into your calculator, you can see 2 places where it crossed the x-axis. That tells you there are 2 real solutions. Now, neither of them had multiplicity. It went straight through. So that's 2 of the how many? This is going to have 4. So, if we were just asked what they were, if there are 2 real, then there must be 2 imaginary to make our 4. Now, what if I phrased it differently? What if I said find all of them? The 2 real ones were 2 and 3. So, 2. 1, negative 5, 8, negative 10, 12. Bring it down. Multiply, add, multiply, add, multiply, add, multiply, celebrate. Okay? Anytime you get 0, you know you're doing it right if you saw that 2 was a root. This has to be 0. All right, so the other one we could see was 3. So we bring it down, we multiply, we add, we multiply, we add, we multiply, and once again, we celebrate. Because we know that remainder has to be 0. Now, what does this gobbledygook of 1, 0, 2 mean? It means 2 is our constant, 0x is our linear term, and x squared is our quadratic. So what I'm left with is x squared plus 2. So if I ask you to give me those 2 imaginary solutions, if it were an equation, roots if we're talking about the function, we would set it equal to 0. We would take the square root, and they actually are plus or minus I root 2. So I've got 1, 2, 3, 4, all done. Any questions? Okay, so today I'm going to go over tiny, tiny, tiny bits of information because you already know it. Today's review trig a little bit more day. And the trig that we're looking at is really just right triangle trig. We're actually going to spend almost half the year studying trig. Trig is not just contained in a little box of right triangles. We can do many, many, many things with it, and we will. But the trig that you currently know is right triangle trig. So you know 3 trig ratios. What are they? Well, we know SOHCAHTOA, and SOHCAHTOA helps us remember those ratios. We know that sine is a ratio of the opposite side to the hypotenuse. And that's what the SO represents, sine, opposite, hypotenuse. We know that cosine is a ratio of the adjacent side to the hypotenuse. And that is what the COS stands for, cosine, adjacent, hypotenuse. And tangent is a ratio of the opposite side to the adjacent side. So we set up those ratios, we use them to solve. Okay? So, Sarah doesn't have anything to do this afternoon because she has such a light load this year that she decides to go fly a kite. Alright? So, yeah. Alright, so here's Sarah. Wait, she's got long hair. There we go. I fixed it. Alright, so Sarah's going to fly a kite. Woo! Alright, so here's her kite way up in the sky.
It's a long kite.
It's a great kite, I know. I am so artistic. Alright, so there's Sarah's kite. Alright. Is everybody good with that? Alright, so we want to figure out how high off the ground this kite is.
12 feet.
Okay, now we would have to add this little distance right here that Sarah's holding it up above the ground. Yeah. But if we want to figure out this height, and we know that she let out 200 feet of string, because we all measure the string when we let out a kite, right? Yeah. All right, and we know that this angle of elevation right here is 42 degrees. Yeah. So we want to find this distance. How do we set that up? It is a ratio of which two sides? The opposite, because this is the angle with which everything is referenced, 42. So x is opposite, and the 200 is across from the right angle, which forces it to be the hypotenuse. So this would be which trig function? Sine. Sine is a ratio of the opposite and hypotenuse. So we would say sine of 42 degrees is equal to the opposite over the hypotenuse. Now, before we punch this into our calculator, we would make sure our calculator is in degree mode. We're eventually going to use a couple different types of angle measurement. We're going to use degrees, we're going to use radians. So right now we need to make sure it's in degree mode. And we're solving for x, so all we have to do is multiply by 200, and we're all done. And I don't have my calculator, so I'm going to count on you guys to be accurate.
How do you finish degree?
Hit the mode button and make sure degree is highlighted. Okay. Do y'all kind of agree? Is everybody showing the same thing when you punch away? What do we get? 133.8?
Yes.
All right, I'm good enough with that. All right, so this is what I write on my quiz tomorrow, and me, Miss Willoughby, doesn't give me full credit. Why?
There's no unit.
There's no unit. All right, this is B. Now, if we were in science, obviously this would all be meters. It'd be measured. But we'll throw a little bit of both at you. Okay, so that's one way we can set up a trig ratio to solve. Do you guys remember doing some of that? Okay, now, let's do a different one. We're going to have no cool story to go with this one because I want to give you class time. So let's say we had just a plain old triangle. This was theta. This is 7. This is 8. All right. First of all, we have to determine which trig ratio. Caleb, what are you thinking? Sine, cosine, tan.
You are going to do tangent.
You sure are. Because this side is opposite, this side is adjacent. You were not given the hypotenuse. It asked you for the hypotenuse, you'd use Pythagorean theorem. But I didn't. I want theta. So we're going to do tangent of theta is equal to the opposite side over the adjacent side, a ratio of the opposite to the adjacent. Now, we're going backwards and solving for an angle. we have to use the inverse operation here, which is inverse tan. So theta is equivalent to inverse tan of 7/8. Then you have old school parents that try to help you with this. They might call it arctan. Same thing. Arctan. All right. So what is theta approximately? 41.2 degrees. All right. And that's basically the two things that can happen. I can either ask you to, given an angle, find a side, or given some sides, find an angle. I can put a triangle inside of a triangle. I can make two triangles that share an adjacent side. We can do a lot of different things, but those two cover the basics. All right, so the solutions for your homework are posted. So give it a try. Check your answers. First two questions on the board tomorrow are the two I'll go over before the quiz.
Can we get here before school and write our questions?
That is cheating. If you get here before school, you can just ask. All right, let's see. Stop.